So I hope you're not going to take the attitude that because it's not on the test tomorrow, I'm not going to pay attention because this is not important. I hope you're not going to take that attitude, right? It's all about the learning and, acquiring skills and tools that you can use later in your math career. So composition of functions is one of those things. And I'm going to actually show, he did an example with the newspaper thing, and I'm going to do another example with you, which sort of helps you to see how you can come up with function which takes into account the relationship that exists in another function, something that should look very familiar to you as we go along. But let me just, first of all, by way of definition, tell you what a composition of functions is. A situation in which you are taking the output of one function as the input of another. So you take the x and put it into this g function, right? And then whatever you get from the g function, you put that into your f function and you get a final result from that. That's the whole essence of compositions of functions. The input of one function, right? Or the output, I should say, of one function becomes the input of the other. So this is the f of the g of x. You saw him put that as a composition of functions. F of g of x means, and another way of him saying that, you saw him do this, is to put f o g of x. It means the same thing. The g function is going into the f function. All right, that's a composition. And you can compose more than two functions, by the way. I could find the f of the g of the t of x, but we're just probably going to focus on two at a time for what we're going to be doing today. Well, let me get to this. Given the table, right? So a table of values can be a function. Doesn't have to be an equation. So I can say my function of x is 1 links to 5, 2 to 3, 3 to 1, 4 to 3, and 5 to 5. That's my function for f. My g function is 1 goes to 6, 2 goes to 5, 3 goes to 4, and so on and so forth. So those are the definitions of those functions. So here's my question now. What's the g of the f of 3? Which means the same thing as this, right? So these two things are equivalent, the g of the f of 3. So let me do the first one for you and see if you can figure out the second one, g of f of 3. I'm going to say, okay, the f of 3 is, where does 3 take me to in the f function? Well, it takes me to 1. The f of 3 is 1. All right. I'm going to say, okay, I found the f of 3. The f of 3 is equal to 1. So what I'm actually going to do now is find the g of 1, because I'm taking the result of this and putting this into the g function. This function is a g function I'm going to put in. So I need to find a g of 1. Well, here's my 1. And if I point to what that takes me to, that would be 6. The answer, therefore, is 6. All right? Let me say that again. The output of one function gives you the input of the other. Okay, so I went from 3 to 1 because that's what my f of 3 is. Then I took that result and went to my x column again, and now I'm looking for the result of putting that x into the g function, which takes me to 6. Did everybody follow that? Does that make sense? Let me check with the room on that. Let me start with Axa and Emily. Okay. Okay, I see a lot of yeses here. That's good. I haven't heard from, I did hear from Axa. Okay, perfect. Good, good, good. Okay, good. Let's try another one now. Let's try the f of the g of 2. Nobody put any answers in, right? I want you to think that through. Take that 2, put it into the g function, take the result of that, and put that into the f function, and tell me what you're getting by doing that. I'll give you 30 seconds to think that through before we get to the answer. All right? Get the g value first. Take that g value, put it into the f function. Okay? All right. Let me erase all of this in the meantime. All right, so I'll take a volunteer. Who thinks they know the answer? Anybody? Anybody can volunteer. And you can put it in the chat if you like. Who thinks they know the answer to the f of the g of 2? Follow the steps that I just went through a few minutes ago for the g of the f of 3 and see if you can get the f of the g of 2 now. All right, so Kayla is asking if it's 5. Not going to comment yet. Is anybody going to agree with Kayla? Or do you have a different answer from Kayla? Harish says yes, he agrees with Kayla. Well, where's everybody else? Sharisa, I think this. Okay, so we have one answer. We have a lot of people, Lisa and Sharisa and Harish, are thinking that Kayla is right. All right, let me ask some specific people here now. Joel, what do you think? Joel, I haven't heard from you. Do you think that Kayla is right? Joel, what do you say to that? You do? Well, let's follow the process through then. Let's see if she's right. So, the G of 2. I'm going from 2 over to, oh, sorry. I'm going from 2 over to the corresponding value in the G column. The G of 2 is 5. Write that down. So I'm going to go now to 5 and ask myself, what's the F value for that? That takes me to this value right here. So you're absolutely right. The F of the G of 2 is in fact equal to 5. Because 5 takes me into 5 in the F column. All right, excellent. Okay, now I wonder what this one means. F of 4. I'll tell you, it just means put the 4 into the F, take that result, put it back into the F, and get your new result. All right, so I'll take another volunteer on that. Let me erase the stuff that's on here now. All right, does anybody think they know the answer to that one? The F of the, you can take a composite function of itself. The F of the F of 4. Okay, Keonta says 1, Sharisa says 1, Emily, Karis. A lot of 1s are popping up. Kayla returns with a 1 as well. The Archana. Interesting. Is there any other answer apart from that? I'm not saying it's right or wrong. I'm just asking if anybody has a different answer. Okay. Let me get specific now. Neil, what do you think about that answer? You think they're right? Or do you have a different answer? Neil, let me ask Neil that. Neil, where are you? Where's Neil? Neil, okay, you agree. Okay, well, let's see if that makes sense. F of the F of 4. So we're going to go from 4. I keep doing that. I'm going to go from 4 to 3. Right? So the F of 4 is 3. So I need to know what the F of 3 is now. Right? So I'm going to go to 3 now and go across back to the F column again, and that is in fact equal to 1. Absolutely 100% correct. All right. Let me just take one arbitrary one and see if anybody, let me see if I can come up with something arbitrary now. Let's say the G of the F of, let's see now, let's see now, the G of the F of 1. No, that's not a good one. Let's try something else. Let's try something else. Of G of the F of 4. I did that already. Or did I? All right, we'll just move on. We'll just move on. All right. Now, let's use some actual equations. Let's use some actual equations. Evaluate the U of the W of 2. So I'm going to do that one for you. Then somebody's going to do the other one after that. This is very simple. It's just like what we just did. I'm going to first of all find the W of 2. There's a W equation. The W of 2 is equal to 1 over 2 minus 1. Okay, that's just plugging 2 into the function. We know how that works. And that is, of course, equal to 1 over 1, which is 1. Then I'm going to find the u, not of 2 anymore, but of the result of that, which is 1. So I'm putting 1 into the u equation now. And that's equal to 1 squared plus 3 times 1 plus 2. And that looks to me like 6. 1 plus 3 plus 2. Okay, as simple as that. All right, here's the next task. I'm going to ask somebody, let me bring this up, to try to find the W of the U of minus 3. All right, let me get specific now. Let me get to Rachel. Rachel, first of all, check in for me, please. Let me know you're there. Great. All right, Rachel, can you tell us what you think? And you can take your time. I'm not rushing you. Take your time and figure out what the W of the U of minus 3 is. All right, without me saying anything, without me giving you any clues whatsoever, see if you can come up with the W of the U of minus 3. Over to you. 2.8125. That's interesting. All right. Okay. Well, let's find out what other people think. All right. Don't put an answer in. Okay. So Eliza got minus 9. I was just asking to hold on. So you don't agree with her answer then, Eliza. Is there anybody who agrees with her answer or has a different answer? Don't put the answer in. Just let me know if you have a different answer or you agree with Rachel's answer. All right. Just let me get some reaction from other people. Got a different answer? Different answer. Interesting. Interesting. Okay. Supposed to use the other equation. Yes, you have to use both equations. You have to use both equations. So let's walk you through it because that answer isn't quite right. So let's walk us through this. All right. So back to you now, Rachel. Here's what I want you to do. I want you to find. Let me ask what other people got. I use both. Okay. Let me get an idea of what other people got. What answer did other people get? You can put it in the chat now. What answer did other people get? And we'll see if that's right. Okay, so Harish got 1. Joel and Charissa and Emily all got 1. Interesting. Interesting. All right. So Rachel, let's work this through in stages now. The inside function is the one you're going to start with, right? So we need to find the u of minus 3. And that's just putting u into the function, not you, Rachel, you, the letter u, right? I'm sure you understand that. So it would be minus 3 squared plus 3 times minus 3 plus 2. Could you evaluate that for me, please, Rachel? So all I did is I put the minus 3 into the u function. All right? When you have an answer, please let me know. What's the u of minus 3? 2. Good. This says once you have this part of it, put that into the w function. So what I'm looking for now is the w of the result that you just got from the u function. The w function is this. So it's 1 over the 2 minus 1. You see what we're doing here, Rachel? Does that make sense? Okay, give me an answer now, please. It is 1. Correct. It is 1. So the first thing that we did is we just looked at function as being a list of numbers. And we went from one column to another column. Now we have actual equations, but it's still the same principle, right? We take the result of one, put it into the other function. All right. How about if you actually had the function itself? Can you compose two functions? Can you take one function and sink it into it? And Mr. Richards did exactly that in his presentation. So let's see if we can do the same thing here. The f of x function is the x squared function. You can see it on the screen right there. Very similar to what he did, by the way. The g of x function is the x plus 3 function. I'll do the first one, f of g of x. So I'm going to take the g function, which is this, and put that into the f function. Anywhere I see an x in the f function, I'm going to replace that with whatever the g of x function is. So here's what this is going to look like. It's going to look like this. X plus 3 squared. So I'm replacing that x in the f function. Excuse me. Hold on, please. Just had to get some water there. Sorry about that. I'm replacing the x in the f function with whatever the g function is. So all of the g function goes into the f function. Of course, I can expand this if I wanted to. X squared plus 6x plus 9. So that's your f of g of x function. Okay, now let's try this the other way, which is to say, I want the f of x function, which is this thing here, to go into the g of x function. Can anybody tell me what they think that might look like? Again, not spinning any wheel right now, just asking you to volunteer. What do you think the g of the f of x function would look like? Right? If we were to compose it the other way. Isaac says x squared plus 3. You're absolutely right. The question that Mr. Richards did was very, very similar to that. X squared plus 3 is absolutely correct. And by the way, you'll notice that the f of g of x and g of f of x are not the same, right? Composing it one way, thank you, Sharisa, by the way. Composing it one way doesn't mean that it's the same if you compose it the other way. F of g of x is not equal to g of f of x. They're not commutative, all right? Okay, now what does this mean? F of the f of x. Hello. Well, all that means is, and we did that on the previous page a few minutes ago, take that f function, put it back into itself. All right. So who thinks they know what that might look like? Putting the f function into the f function. All right. Again, I'll take a volunteer on that. F of the f of x. And by the way, these are your functions. I guess I need to be able to see the functions. So let me move these up here. F of the f of x. Isaac says, and Harish says pretty much the same thing. It's the x squared, which is the same thing as the x4 function, absolutely. Which is x to the power of 4. How about if we did that the other way? Excuse me. Which is, and thank you, by the way, Harish and Isaac, for that. How about if I took the g function and put that back into the g function? What would that look like? Okay, so I don't see any responses to that question yet. G of x. G of the g of x. So x plus 3 plus 3. Absolutely. And of course, we can simplify that to x plus 6. Okay, thank you, Keontae. Here's an interesting one. The g minus 1 of the g of x. Okay, that's interesting. The g of x function is x plus 3. Do we know what this g to the minus 1 means? Don't think now in terms of what we were doing with exponents. It's not really an exponent. It's not. Who remembers what g, let me move this aside here. When you have a function and you talk about g to the minus 1, what does that mean again? Or f to the minus 1? It is in fact. You guys remember stuff from grade 11. It's the inverse function. So here's what we're going to do. We're going to find what the inverse function is first so we can use it, right? So here's what the original function was. The original function is g of x equals x plus 3. I'm going to put y equals. I'm going to say y equals x plus 3. Does anybody remember how we find inverses? We did inverses when we were doing the log and exponential functions because those are inverses of each other. So we know the first step is to flip the x with the y. So we'll do that right now. So x is equal to y plus 3. And then, of course, we have to do what? Isolate the x. So y is equal to x minus 3. So my g to the minus 1 function is equal to x minus 3. That is my inverse function. So what I'm asking you to do now is to, now, so this is my g, and by the way, let me remind you what my g of x function is. My g of x function is x plus 3. That's my g of x function. So what I'm looking for now is the g to the minus 1 of the g of x function. Can somebody give me a response to that? You've been doing really well so far. Not everybody, but I've heard from quite a few of you, right? Put those two together. Put the g of x function into the g to the minus 1 function, inverse function, and tell me what you're getting for that. What is that equal to? Anybody? Sharisa says it's just simply x. Okay? Is she right? Is that the answer? Arish says yes. He agrees. So Kamok, got to tell you that I have to leave for an appointment at 2:15, Travis says. Okay, that's in about 10 minutes then. Okay. Kayla says yes and Ava says yes, and that is absolutely true. Now, I have a little thing to mention to you. The fact is that that's not a coincidence that you got x. If I give you any arbitrary function and I ask you to find the g to the minus 1 of x of that function, doesn't matter what the function is, you always just end up with x. You might want to make a note of that somewhere, because that could end up being actually, I guess I said I wasn't going to put any of the compositions of functions on the test. Maybe I should rethink that. Anyway, that's the fact that anytime you take a function and put it in its inverse, or take an inverse and put it in its function, it actually works both ways. You always end up with just with simply x. One example of that coming up, which we'll get to shortly. But let's keep going. Oh, here we go. The example came up quicker than I thought. F of x is equal to that function. Show that f of the f to the minus, please do composite. Jeremy seems to be into this composite function stuff. Anyway, show that the f of the f minus 1 of x is equal to the f to the minus 1 of f of x for all values of x. So I'm saying, I just said to you a few minutes ago that, and this is going to be a little bit technical, right? What we're going to do. Oh, please, no composite. Oh, sorry, I guess I misread that. I guess I misread that. I thought you were saying, bring on the composite functions. Well, anyway, let's keep going here. Now, this involves some fairly involved algebra, but knowing this class, I'm sure you can handle it. We're going to show that if I take the inverse function and put it into the original function, it will actually give me the same as putting the original function into an inverse function. In fact, you always get x. You always get x. Study for logs and social. Listen to this, man. Okay, let me keep going here. Let me keep going. Let's find the inverse function. So let's start by saying that y is equal to x over x plus 2. This is good practice for developing your algebra skills. Remember that my goal now is to end up with a new function that has the x and the y flipped. So I'm going to say that x is equal to y over y plus 2. But as usual, I have to isolate the y, right? Can anybody suggest my next steps in getting the y on its own, right? And by the way, I'm going to show you what the nature of an inverse function is in a little while. But let's just talk about doing this. I want to isolate the y. Can you suggest an algebra step? Multiply both sides by y plus 2. Thank you, Jeremy. And thank you, Harish. We're going to do exactly that. And I'm sure you meant y plus 2, Harish, rather than x plus 2. I'm sure you meant that. Okay? So cross multiplication is absolutely what we're going to be doing. So it's x bracket y plus 2 is equal to y. Okay? What do we do next? Remember, our goal is to get to that y on its own. That's where we're looking. That's what we're looking for. We need to get that y on its own. So any suggestions as to how I might be able to do that? If you think back to that stuff we did with the logs, so here's where the stuff, Jeremy, you're talking about studying for the logs. I did a question with you where we had to solve a log equation, sorry, an exponential equation where the bases were different, and something like what we're about to do now came up. But let me throw it over to you. Multiply both sides by x plus 2. We've done that. And we got this. What do you think next? Try to isolate the y. I have the y inside of a bracket on one side and the y by itself on another. Multiply out the x. Are you saying distribute the x, Jeremy? Is that what you're saying? Distribute the x into the bracket? Okay, let's do that. That's a good idea. So xy plus 2x equals y. That is a good idea. All right. But what's next? I'll give you a hint. No, not going to give you a hint. Okay, no hint. You're on your own. What do we do next? We want to isolate the y. I did say there was some algebra. Move the y to the right. Okay, which y are we talking about? Because there's a y on the right already. The y to the left. So take the y from the left, put it on the right, you're saying? I'm going to do a little bit different. I know I know why you're doing that. I want all my y's together. So I'm going to take the y minus xy on this side. I'm going to have 2x on this side. All right? Nothing wrong with what you said. All right? You're really trying to get your y's together. But I just think since there's a y already on that right-hand side, why don't I bring another little cousin y over to him so that they can both get together and sort of, have some little family time there. So all the y's are kind of together, but there's the x that's still there. So how do you think we're going to deal with that, folks? Divide both sides by y? Not quite. Not quite. Not quite. Factor. Here we go. Here we go. So what am I factoring by doing? What am I factoring out in this case? Factoring out the y. Good. And what's left when I factor out that y? Not just Jeremy now, folks. I mean, I'm expecting full participation from everybody. When I factor out that y, what am I left with? Right, 1 minus x. Well done. I'm hoping that next step is now obvious as to what to get the y on its own. Thank you, Elizabeth. Thank you, Liz. How do I get that y on its own now? There's only one step left, one last step left to get that y on its own. Divide both sides by 1 minus x. Well done. So y is equal to 2x divided by 1 minus x. That's actually your inverse function. I know that took a little bit of work. Let's write that down. So the original function was an f function, I think. Yeah, f. So my f to the minus 1 of x is equal to 2x over 1 minus x. That's my inverse function. Now, let me remind you what an inverse function actually does, right? We go back to my original function for a minute here. My original function was this function right here, x over x plus 2. Now, if I put any number into that function, in fact, let me just sort of give you the choice, right? I'm going to pick somebody at random here. Riddy. Riddy, are you there? Where's Riddy? Riddy, give me any number between 1 and 10. It doesn't matter which number. Any number between 1 and 10. 2. Okay. I'm going to find the f of 2. I want to show you what an inverse function actually does. And then we come back to what we're doing here, the composition stuff. The f of 2, I just circled the function, is equal to 2 over 2 plus 2, which of course is 2 over 4, which is a half. Okay? All right, that's the number that Riddy gave me. Turns out that when you put 2 into this original function, you get a half. What do you think would happen if I put the result of this is a half? That's the result, a half, right? Put 2 in, I get a half out. Here's my inverse function. What do you think would happen if I put a half into this function? Give me a prediction on that. Putting a half into this function would give you what? What would your suggestion? What do you think would happen if I put a half into the inverse function? Anybody give what you think the result would be? Anybody? Right? You'd get a half back, you're thinking, Harish, if I put a half. So I want to ask, here's what I'm asking. What do you think the f minus 1 of a half is? Do you think it's equal to a half? Is that what you're thinking, Harish? Is Harish right? Putting a half into the inverse function. Remember, would it be the opposite? Meaning what, really? Okay, Travis. Meaning what, really? What do you think? Oh, you mean like 2. So it gives you back what you started with. Because that's what a function does. Sorry, inverse function does. An inverse function reverses what a function does. This function took a 2 and turned it into a half. So the inverse function should take a half and should, theoretically, turn it back into a 2. So I'm going to erase this, see what we actually get. So here's what, I'm using Ridley's numbers now, right? F of a half using this, remember, this is my inverse function right here. I'm pointing to it right now. That's my inverse function. It should be equal to 2 times a half over 1 minus a half. Okay? 2 times a half should give me 1 over 1 minus a half should give me a half. All right? What's 1 divided by a half? Anybody know what 1 divided by a half is? It is 2 because it's really multiplying by the reciprocal. All right? It's equal to 1 times 2 over 1, which is in fact 2. So is it a coincidence that what really gave me work? No, it is not a coincidence at all. Any number that we chose, whether it was 2 or 9 or a million, I mean, I said between 1 and 10, but I just wanted a number that was easy to work with, would have given us a result, and that result, put it back into the inverse, takes us back to the original. So that's a bit of an off-topic thing. I just thought I'd tell you what an inverse function does. Not entirely off-topic, actually. But let me get back to this now. Let me get back to this. So what we're about to do now, I'm going to erase all of this stuff here. What we're about to, so I'm going to write down the 2 functions that we're playing with here. So f of x, actually f of x is right here, right? I don't need to write that down, it's right there. F to the minus 1 of x is equal to, I'm just going to go back and show you again. It's 2x over 1 minus x. 2x over 1 minus x. All right? So, according to this thing here, so I'm not gonna do it both ways. I think if I just do it one way, then you might get the point. I'm going to put this function, this inverse function, that's what this says, f of minus 1. I'm going to put this inverse function into the original function. Right? There's a lot of algebra involved here, so please try to stay with me on this. I'm going to say it again, I'm going to put this function into the original function. I'm putting the inverse function into the original function. So here it comes. The f of, I'll just put the little thing like that, of the f to the minus 1 of x is equal to, so anywhere I see x, I'm going to put 2x over 1 minus x is equal to 2x over 1 minus x over 2x over 1 minus x plus 2. I know that looks scary. I know. But we're going to work our way through it. But before we work our way through it, I already told you what the answer is going to be. If you are listening very carefully to what I just said a few minutes ago, you know what I'm supposed to get by putting the inverse function into the original function, right? What did I say the answer was always going to be? Anybody? Anybody out there? Hello? Look at you guys. Well done. Well done, Harish. Well done, Keontae. Well done, Riddy. I said it was going to be X. So we're going to do that right now. And you know what? Because I think I'm going to run out of room, let me copy this onto a brand new page. All right? I don't think I'm going to have enough room on this page here. So let me come over here and paste that in. Okay, so watch carefully now. Now, remember that if I am trying to simplify this, I should make a common denominator of the bottom of this. So the top is going to stay as 2x over 1 minus x. But on the bottom, I'm going to create a common denominator of 1 minus x. All right? So on top of that, I'm going to end up with, hopefully everybody's following this, 2x plus 2 times 1 minus x. I hope that makes sense to everybody. Because what I've done is I've said put this 2 over 1, if you like. The common denominator is 1 minus x. So what do I multiply 1 minus x by to get this 1 minus x down here? It's just going to be 2x, so that stays there. What do I multiply this 1 by to get 1 minus x? Is 1 minus x 2 times 1 minus x. Okay, let's move on. Let's move on. So the top is still 2x over 1 minus x. The bottom is going to become 2x plus 2 minus 2x over 1 minus x. Right? I just simply simplified, distributed the 2 into the bracket. Okay, let me put the result over here. So that's 2x over 1 minus x over, this simplifies to 2 over 1 minus x. What's my next step, folks? I have fraction over fraction. What do I do to finish this up? Right? I have one fraction divided by another fraction. Everybody remember when we were doing those trig identities, what our next step is? Cross multiply. I wouldn't call it cross multiply. Multiply by the reciprocal. I like the way AXA put it. So I'm going to have 2x over 1 minus x multiplied by 1 minus x over 2. Good. Can I simplify this? Can anybody see how I can simplify this? Anybody? Anybody? Anything that I can knock out? Anything I can cancel out? Actually, yes. Those 1 minus x's can be cancelled out. That cancels with that. So I'm really left with 2x over 2, which, yes, is just simply x. Okay, thank you, Kayla. So there you go. Did we expect that? Yes, we did. A bunch of you, Riddy and excuse me, and Keontae and Harry said, yes, that was what I expected to get. I should just get x. And if I did it the other way, I still get x as well. All right, let's move this along. Here's one example I'd really love to finish with you, to do with you before we finish the class today. The formulas for the circumference and area of a circle are, and they give it to you. The circumference is 2 pi r, and the area is pi r squared. That's stuff you learned back in, I don't know, grade 10, or probably before grade 10, probably from elementary school. Develop a composite function in its simplest reduced form that could be used to determine the area of a circle based on its circumference. I want you to think about this, right? If I wanted to get the area of a circle, right, could I get that area if somebody gave me the circumference of the circle? The answer to that is yes. Now, what you would probably do is take the circumference, work out the radius, take that radius, put it into the area formula, and get your area. So it'll be a two-step process. But what if we could combine them into one? What if we could compose the circumference function into the area function? Actually, we can compose it either way. We can compose the area function into the circumference function. But this is asking us to come up with a function that goes from A directly to C. So I'm going to write down those two formulas again, right? My A function is pi r squared. My C function is 2 pi r. What I really want to do, right, is to see if I can put this function here, not with A and R, but with A and C. That's my goal, right? I want to be able to put the circumference directly into something and get the area. Can anybody suggest a way that I might be able to start doing that? Right? I want to be able to compose these two functions together. I want to be able to sort of meld these two functions together, right? I'll give you a hint. They both are connected by the variable r, by radius. They're both connected by radius. Is there a way that I might be able to write my area function, not in terms of radius, but in terms of circumference? Can anybody think of a way that I might be able to do that? We're about 15 minutes left. Any suggestions as to how I can start that process? Right? I want to be able to put this function inside of this function over here. That's what I'm trying to do. No ideas? Nobody have a clue as to how I might be able to do that? All right. Let me give you a little push start then. Nobody? Nobody? Anybody? Nobody? All right. 2 pi r squared, Joel says. 2 pi r squared. Mm, mm, Not quite what I had in mind. Let me show you what I had in mind. Let me come back over here. What if I said, okay, I have a function that gives me the circumference based on the radius. What if I were to rearrange this function right here? What if I were to rearrange this one and isolate the r, right? Well, yeah, I can do that. R is equal to c over 2 pi. Can we all agree on that, by the way? Does that make sense? If I'm trying to get the r on its own, then I could just simply divide both sides by 2 pi. Harry says yes, Keontae says yes, and Sharita says yes. Great. What do you think I'm going to do now with that? Since I've isolated the r, wouldn't I be able to take that over to my area function and maybe make a substitution? I sure can. So what I'm going to do now is I'm going to come over here and say, instead of a equals pi r squared, I'm going to say that a is equal to pi times c over 2 pi squared. See what I just did there, folks? See what I just did there? I took out the r that was in the area function and replaced it with something which relates to the circumference. I'm going to try to simplify this a little bit, right? So that's equal to pi. Now let's square the top and square the bottom. So you're going to have c squared on top. Then you're going to have 4 pi squared on the bottom, right? So I've just simply squared the c over 2 pi. That's all I've done. Now, can this be simplified just a little bit? Yes, it can. This is pi over 1. Doesn't that pi there cancel down a little bit? So 1 pi here, and there's a pi squared on the bottom. So shouldn't that be equal to this? And this function here is an a of c function. This function doesn't depend on r anymore, right? We've taken the r and we've kind of brought it out of the equation. So this works out to be c squared over 4 pi is what this works out to be. C squared over 4 pi. What happened to the pi squared? Well, one of the pi's that was on there, what was there before, canceled out with that pi on the bottom. So what we're saying now is that if you brought a circumference to me now and asked me for the area, I'm not going to work out the radius first and then take that radius and put that radius into the area function because I now have a direct link between circumference and area. That's what I'm saying, right? This function here is my a of c function. This function does not depend on radius, right? Does not relate, it does relate to radius, but it's related to radius through, because of the relationship between circumference and area. I can now figure out what the area is if you just tell me what the circumference is. I'm not going to work out the radius and go through all of that. I'm just going to go ahead and plug it into this function. I want to make sure people see what I'm saying here. I'm just going to do a quick check again to make sure that I haven't left anybody behind. Shiabon, how about you? Does that make sense what I just did? Shiabon, are you there with us? Okay, does it make sense to us? Well? Does that what I just did make sense to you? Does that follow? Right, so I'm about to use this function right now, but I want to make sure that it makes sense to you. Do you follow that, Shiabon, or you want to go over it again? Because I can do that if you need me to. Does it make sense? It does. Okay. Let's come down to here now. Use a composite function obtained in part A, so part A is this part up here, to determine the exact value for the area of a circle, given that the circumference is 8 pi centimeters. Remember your units in your answer. So now we're saying, I want to use it. I'm going to write this function down again. A of c is c squared over 4 pi. That's my function. Now I'm saying to you that I want to figure out the area of a circle, and I'm going to give you the circumference. And I just want you to be able to give me the area based on the circumference. There is a relationship between circumference and area. There clearly is. And this is the function that gives us that relationship. So I'm going to go ahead and plug in this value, the 8 pi, into this equation. I'm not putting this into a formula for circumference. Yes, I know what the circumference is. Circumference is 2 pi r. Yeah, we know that. We could work our way backward through that, but I'm just going to put it into this function right here that links circumference directly to area. Okay, so let's see how this works. So I'm really trying to find out the A of 8 pi is what I'm trying to do. So that's equal to, excuse me, that's equal to 8 pi squared divided by 4 pi. All right, take the circumference, square it, divided by 4 pi. That should be my area. Let's keep going. 8 pi squared, 8 squared is 64. Pi squared over 4 pi. 4 goes into 64, I believe, 16 times. Is that right? 4, 16? I think so, yeah. The pi's are going to cancel out. Not completely. Not completely. So 16 pi is my answer. Now, it says remember the units in your answer. Can somebody help me out with that, please? What units would make sense for a question like this? Centimeters I'm hearing, and centimeters squared I'm hearing. Centimeters squared as well. All right, so I'm getting centimeters. Joel says centimeters, and then 3 of you are saying centimeters squared. I wonder who is right. Okay, Joel is changing his tune now. Yeah, it's an area question, right? To determine the exact value for the area of the circle. So this is actually, and this was in centimeters, by the way. So this is actually centimeters squared.